Hello everyone, this is That Math Guy. In today's video, we're going to be going over some wind and water practice problems. So if you remember from the last video, we went over the basics of how these problems work, how to use the basic equation D equals RT to solve for our unknown quantity, and we went through some pretty basic examples. In this video, we're going to be doing some more intermediate problems that require just a little bit more work, but still aren't too challenging. And as we go through these, I encourage you guys to try and work them out for yourself before you watch me do the solution. Just go ahead and pause the video once you read the question, and then once you have an answer, go ahead and play it and see if you get the same answer as me. So let's get right into it. Okay, so in this first question, we have a cargo ship and it leaves its port and it's setting sail for open waters at a constant speed of 24 miles an hour. On its way out, it's going to pass by 3 buoys which are 8 miles away, 12 miles away, and 20 miles away from the shore. We need to find how long it takes for the ship to reach the last buoy, as well as how long it takes to go from buoy 1 to buoy 2, and from buoy 2 to buoy 3. So if you look up here, I have a pretty rough drawing of the problem. So this red buoy is going to be buoy 1, orange will be buoy 2, and the green will be buoy 3. So the first thing I want to do is write down our equation. Distance is equal to rate times time. That's the equation I'm going to be using to solve this. And next we want to just take all the information that we can out of this problem. So our rate is going to be constant at 24 miles an hour, so we'll write that down. And then next we have 3 distances that we need to consider. So we have distance 1, which is to the first buoy, is going to be 8 miles. Distance 2 to the second buoy is going to be 12 miles. And distance 3 to the third buoy is going to be 20 miles. Alright, so first let's find how long it takes for the ship to reach the last buoy. So to the last buoy, we know that's going to be a distance of 20 miles. And our rate is going to be 24 miles an hour. So if we just take both of those values, plug them into our equation, we get 20 miles is equal to 24 miles an hour times our time. Now if we just divide both sides by 24, we get 20 over 24 hours is equal to our time. We simplify that and we get 5/6 of an hour. If you want to get fancy, you can go ahead and convert that into minutes. You can multiply that by 60. You see that it is 50 minutes to the last buoy. Alright, so now from buoy 1 to buoy 2, our distance is going to be the difference in between those 2 buoys. So what I mean by that is, we know that buoy 2 is 12 miles from the shoreline and buoy 1 is 8 miles from the shoreline. So if we want the distance from buoy 1 to buoy 2, we need to subtract those 2 distances. So it's going to be 4 miles because 12 minus 8 is 4. And just like before, our rate is still 24 miles an hour. And now we have 2 of our unknowns, so we'll go ahead and plug that into our equation just like last time. So we have 4 miles is equal to 24 miles an hour times our time. Divide both sides by 24 and simplify that, and we get a time of 1/6 of an hour. And just like before, we'll multiply that by 60 to get a total time of 10 minutes. And then same process from buoy 2 to 3. This time we're going to subtract 12 from 20 to get a distance of 8 miles. 8 miles in between buoy 2 and 3. Our rate is still 24 miles an hour. We'll go ahead and plug those in. 8 miles is equal to 24 times our time. Go ahead and divide both sides by 24 once again. Simplify that down, and we get 1/3 of an hour is equal to our time. And lastly, of course, we're going to multiply that by 60 to get a time of 20 minutes. Alright, so in problem 2, we have 2 planes, A and B. They're going to make the same 3,000 mile journey every week. We know that plane A is going to fly at a speed of 250 miles an hour, and plane B flies at 400 miles an hour. And we want to know how much longer a flight on plane A will take than a flight on plane B. So we know our distance for each is going to be the same, 3,000 miles. And we have 2 different rates. We have R sub A is going to be 250 and R sub B is going to be 400. So I'll just go ahead and write all that down. We got our distance and our 2 rates. And now if we solve for our times of plane A and B, we're going to end up with two different times that we can compare. So let's go ahead and do that. First, the time for plane A. So our distance is going to be 3,000. Our rate is going to be 250, so we just go ahead and plug those into the equation. 3,000 is equal to 250 times our time. Go ahead and divide both sides by 250. Simplify that down, and we get a time of 12 hours for plane A. It's a pretty long flight. I don't think I would want to be on that plane. Alright, let's see. How long does it take for plane B? So it's going to be the same distance as before. This time we're moving at 400 miles an hour. So we plug those in here. We get 3,000 is equal to 400 times our time. Divide both sides by 400. Go ahead and simplify that down. And we're going to get time for plane B is 7.5 hours. Okay, so now that we have both of our times for plane A and for plane B, let's go ahead and compare them. So to find the difference, or how much longer it takes for plane B to fly than for plane A, we'll go ahead and subtract these two. So our time difference is going to be 12 hours minus 7.5 hours. It's going to give us an answer of 4.5 hours. So that means that plane B takes 4.5 hours longer than plane A to make this 3,000 mile trip. And if you want to get fancy, you can go ahead and convert that 0.5 into minutes. And all you have to do for that is keep that 4 the same. It's going to be 4 hours. And then multiply that 0.5 by 60. So 1/2 times 60 is 30. So we know that 4.5 hours is 4 hours and 30 minutes. Problem 3. Here we have a straight stretch of road. It's broken into 3 sections. It's going to take a car to go it's going to take it 20 minutes to go from point A to point B, 15 minutes to go from point B to point C, and then 45 minutes to go from C to D. And we know that the distance between each point is the same at 30 miles. We want to know the speed of the car in each section. Okay, so let's write down what we know. Start off with our formula, D equals RT. Really want to make sure that's locked into your brain. Next up, our distance. Each distance of each section is going to be exactly the same, 30 miles. And now let's make a time for each section. So time 1 will be from A to B, it's 20 minutes. Time 2 will be from B to C, will be 15 minutes. And time 3 will be from C to D at 45 minutes. Alright, so let's break this down section by section. Oh, excuse me. If you remember from the last video, we want to convert our times from minutes to hours in order to get consistent units. Since we're solving for speed, we're probably going to want that in miles per hour. Right now, if we solved it, we'd get miles per minute, which is fine. You can do that, but I think it's much better to have it in miles per hour. So let's go ahead and convert these times into hours, and you can do that by just dividing by 60 because we know that there's 60 minutes in an hour. So for time 1, 20 divided by 60 is going to be 1/3. 15 over 60 is going to be 1/4. And 45 over 60 is going to be 3/4. So now we have all of our times in our desired units. Let's get cracking. So from A to B, distance is going to be 30, and our time is 1/3. Go ahead and plug those in. To get 30 is equal to our rate times 1/3. Now we're going to divide both sides by 1/3. So we have 30 divided by 1/3. And hopefully you know that when you divide by 1/3, that's the same thing as multiplying by 3. We actually get a bigger answer than before. So our rate is going to be 30 divided by 1/3, which is the same as 30 times 3, which is 90 miles an hour. It's pretty quick. Alright, let's go from B to C. So B to C, it's going to take us 1/4 of an hour. Distance is the same. Plug both of those into our equation. We get 30 is equal to our rate times 1/4 of an hour. Divide both sides by 1/4, like before. And then, just like before, dividing by 1/4 is the same thing as multiplying by 4. So we're going to do 30 times 4, which is 120 miles an hour. You can tell this guy is absolutely moving 120 miles an hour. He's probably breaking some speed limits. Well, let's see if he continues this pace. So last section, C to D, same distance, different time. Let's plug in 30 miles and 3/4 of an hour. So here we got 30 miles is equal to our rate times 3/4 of an hour. We are going to divide by 3/4. on each side. So now this is a little bit more tricky because our other two times were just 1 over a number. This is 3 over our total fractional amount. But you can still flip the fraction the same way. So before, when we divided by 1/4, we multiplied by 4. All we did is we multiplied by the reciprocal of our time. And the reciprocal is just you switch the top and the bottom, or you switch the numerator and the denominator, however you want to say it. So instead of dividing by 3/4, we're going to multiply by 4/3. So we're going to do 30 times 4 divided by 3. And when you do that, you see that we get a rate of 40 miles an hour. And that's because 30 times 4 is 120, and 120 divided by 3 is 40. So you can see he slowed down a fair amount from B to C and then from C to D. So maybe he passed a cop at point C, I don't know. But he's driving at much safer speeds. Alright, that's all I have for you guys today. Thanks for watching. Thanks for listening. Please like and subscribe for more. I'll see you in the next one.